You know when you use an online translator and it just works instantly? It feels like actual magic. But today, we're going to pull back that curtain. We're going to look at the machine, and we're actually going to build the AI that makes it all possible, piece by piece. Okay, so let's just dive right in. You type a sentence, or maybe you say it out loud in one language. Let's take this phrase in Portuguese, for example, este é o primeiro livro que eu fiz. And then, in less than a second, boom, you get a perfectly coherent English translation. So how? How does that happen? Well, it's not magic, but it is a brilliant piece of engineering called a transformer model. And we're about to see exactly how it works. So, first things first. Computers are, amazing at a lot of things, but understanding human language? Not really one of them. They live in a world of numbers. So the very first, most fundamental challenge is just to translate our words into their language. And that process has a name. It's called tokenization. We take a sentence and we break it down into these little pieces. Sometimes they're whole words, sometimes just parts of words, and we assign each one a unique number. This is step one for getting the machine to read. And this is where it gets really clever. A complex word like searchability isn't just one single token. No, the AI is smart enough to break it down into its root, search, and its suffix, ability. This is huge because it helps it understand the meaning of words it might not have even seen before.
Okay, but this creates a whole new problem. If every word is just a number, a sentence basically becomes what's called a bag of words. It's just a jumble of numbers with no order. I mean, the meaning of dog bites man is completely different from man bites dog, right? But in a simple bag of numbers, they could look exactly the same.
All right, so how do we solve this? How do we give the AI back that sense of sequence? The solution is this really elegant mathematical trick called positional encoding. It's a way of adding a second layer of information, a unique fingerprint, if you will, to each word that tells the model its exact position in the sentence. And this visual right here perfectly illustrates what's happening. Each row you see represents a word's position, and each column is another dimension of that positional fingerprint. You can see how each position has its own unique wave-like signature. So by adding this map to the word's meaning, the AI now knows not only what a word is, but also where it is. Problem solved. Okay, so our AI can now read words as numbers, and it knows what order they're in. But language is all about context. In a sentence like, the robot picked up the ball because it was heavy, how does the AI figure out that it refers to the ball and not the robot? The answer is a truly revolutionary mechanism called self-attention. So what is self-attention really? At its core, it allows the model, for every single word it's looking at, to look back at all the other words in the sentence and decide which ones are the most important for understanding this specific word. It literally learns how to pay attention to the right context. The easiest way to think about this is like a three-step process. For every single word, the model generates something called a query. You can think of this as the word raising its hand and asking, hey, to figure out what I mean here, who else should I be listening to? Then, in response, every other word in the sentence presents its key. The key is like a little label that says, here's the kind of information I have. The model then compares that query to every single key to find the best matches, and it calculates a relevant score for every word pair. And the final step? Based on those scores, the model pulls information, the value, from the most relevant words. Words with high scores get their meaning amplified, and irrelevant words just get quieted down. And just like that, the word it learns to pay way more attention to ball than to robot. But wait, it gets even cooler than that. The model doesn't just do this once. It uses what's called multi-head attention. This means it runs that whole query key value process multiple times, all in parallel, from different points of view. It's like having a team of experts all looking at the same sentence. One is focused on grammar, another on meaning, another on long-distance connections, and this gives the model a much, much richer understanding of the text. All right, so we've got our core components: tokenization to read words, positional encoding for order, and multi-head attention for context. Now it's time to assemble all these pieces into the full transformer architecture. And for all its complexity under the hood, the high-level design is beautifully simple. It just has two main parts, the encoder and the decoder. The best way to think about it is like this. The encoder's whole job is to read and understand. It takes that original Portuguese sentence, and using all those attention layers, it builds this really rich numerical idea of what it means. Then you have the decoder, and its job is to write and translate. It looks at what the encoder understood and begins generating the English sentence one word at a time, paying attention to both the original meaning and the English words it's already put down.
All right, this is the moment of truth. Let's fire up our fully assembled AI and see it perform a real translation.
So we feed it this sentence in Portuguese. The encoder reads it, the decoder gets to work, and look at that. It works. All those layers we talked about, tokenization, positional encoding, attention, they've all come together to produce a perfect result.
But this next part is what's really, truly mind-blowing. Because the model learns the rules and patterns of language, not just words. It can make these incredibly smart guesses about words it has never, ever seen before.
I mean, just look at this example. Believe it or not, the words triceratops and encyclopedia were not in the model's original training data. It has literally never seen these words before, and yet it handles them perfectly. This is what true learning looks like. It's not just memorizing a dictionary. It's learned the underlying rules of how to handle unfamiliar words, and that is what makes these models so incredibly powerful.
So let's do a quick recap of our journey. We saw that an AI first has to turn words into numbers using tokens. Then it uses positional encoding to get a sense of word order. The secret ingredient is that attention mechanism, which lets the model focus on what's important for context. And it's all put together in that elegant encoder-decoder structure that reads one language and writes another.
And that really brings us to the big picture, doesn't it? We've just walked through building an AI that can handle the incredibly complex and nuanced world of human language. It leaves you with a really fascinating final thought. If AI can achieve this, what other massive, complex challenges are just waiting for a similar breakthrough?